classifying triangles. Okay, let's take a look at these triangles here. I'll pause the video and see if there's some way that you could categorize or classify these triangles. Okay, so we're going to come back to this picture later. First, we're going to discuss how to classify triangles based on their sides. The first triangle we're going to talk about is an equilateral triangle. You can see the root word equal, and that just means that there are 3 equal sides and 3 equal angles. And since triangles add up to 180 degrees, if you divide that by 3, you will always get 60 degrees in an equilateral triangle. The second triangle, based on its sides, is an isosceles triangle, which has 2 equal sides and, as a result, 2 equal angles. So in the picture, you might see tick marks here and here that show the 2 sides are equal. And the third triangle is called a scalene triangle, which has no equal sides and no equal angles. Each side is a different size, so you might see something like this with the marks where you have 3 different sides. Okay, next we're going to talk about classifying triangles by angles. So the first triangle is called an acute triangle, where all the angles are less than 90 degrees. So in the picture you can see each of those are going to be smaller or less than 90 degrees. Next, we're going to look at a right triangle, which just means that it has 1 right angle. And a lot of times that's shown with the box in the corner. And lastly, we have an obtuse triangle, which has an angle that is more than 90 degrees. Sometimes I use the corner of my paper to kind of guide me when I'm looking at triangles to compare it to that 90-degree angle. Another way people remember this is acute. Acute kind of means small and cute. Obtuse usually means large, so anything greater than 90 would be obtuse. Okay, so now we're going to take a look back at this picture and decide which types of triangles these are. So in A, I can see that I have an isosceles triangle based on the tick marks, and because this angle here is actually obtuse, just slightly over 90 degrees, I can see that this would be an obtuse isosceles triangle. In B, I notice that each of these sides are different sizes. So this would be a scalene triangle, and also based on the angles, I can see they're all less than 90 degrees, so this would be an acute scalene. C, notice that the 2 tick marks are showing 2 same sides, like A, and all of the angles again are less than 90, so this would be an acute isosceles. D, we can see a clue there in the left-hand corner that is in a right angle, and also these sides are the same, so we can say that this is a right triangle that is also isosceles. In E, down below, we see that there are 2 sides that are the same, and each of the angles are less than 90, so this would be an acute isosceles. F, we can see has equal sides, which also means equal angles in each here. So this would be an equilateral triangle. And we use equilateral for both angles and sides. G, again, we have all sides that are the same, which means all angles are the same. So G is also an equilateral triangle. And lastly, we have H, which has 3 different sides and 3 different angles, one including an obtuse angle. So this would be an obtuse scalene. Okay, so now we want to figure out how do we calculate a missing angle within a triangle. Well, we know that all three angles of a triangle always add up to 180 degrees. Now we can use that information in our first example. So here we have two angles that we know of, and we're trying to find angle A. So if I know that they all add up to 180, I can set up an equation here that allows me to solve for A. So my first step, go ahead and move this over here, I can add together my numbers. So here 36 and 57 give me a total of 93. And then I'm going to bring down the rest of my equation. Now I can solve for A by subtracting 93 from both sides. These cancel out, and A just equals 97 degrees. In example 2, we have a similar problem, except for this time we have a angle with a box, which we know means it's a right angle, or 90 degrees. So again, I'm going to set up my equation. So I have 90 plus 34 plus x equals 180. And if I add 90 and 34, I get 124. Then bring down the rest of your equation, plus x equals 180. Now I can subtract the constant from both sides, so I can get my variable alone, and x just equals 56 degrees. And I usually like to look at my picture just to make sure that makes sense. So 56 degrees is about a half of 90 degrees, a little over, so that looks pretty consistent with my picture. Okay, in this picture, this example, we have something a little bit different where we have a coefficient in front of the variable. So I'm still going to set up my problem the exact same way. 48 plus 87 plus 2x equals 180. And if I add 48 and 87 together, I get 135 plus 2x equals 180. So now this is turned into a two-step equation where I'm still going to subtract my constant from both sides, which will leave me with 2x on the left side equals 45. And lastly, I need to divide by 2. Those twos just equal 1, and x equals 22.5 degrees. Now, that doesn't mean that the angle is equal to that. Remember, this angle here is actually equal to 2x. So if we plug that in, 2 times 22.5 equal 45 degrees. So we really could have stopped at this step, knowing what 2x was equal to. In this problem, again, we're given two angles, and we're trying to find out the missing angle, which is y plus 1. So if I set up my equation, 35 plus 115 plus y plus 1 equals 180. Now in this case, I have three like terms that I can put together. I can put the 35, 115, and 1 together, which equals 151. And then I'm going to bring down the plus y equals 180. Now I can subtract the constant 151 from both sides. These cancel out, and y equals 29. Now if we plug that back in to here, we have 29 plus 1 equals 30 degrees for that angle. In this example, we're given the 50-degree angle, but we don't know what the two missing angles are. Now, based on the angle marks, I know that this is an isosceles triangle, because I've got the two marks at the bottom here and here that are the same, and then the 50 degrees is a different angle. So in this case, if I know these two angles are the same, I can go ahead and put in C and C here. And so I have 50 degrees plus 2C equals 180 degrees. So I can subtract my 50 degrees from both sides. That leaves me with 2C equals 130. And if I divide by 2 on both sides, C equals 15. Now since this is an isosceles triangle, 115. Since it's an isosceles triangle, both of these angles are equal to 115. In this example, we're given the angles but not a picture. But we can still solve for the missing value k the same way. So 42 plus 20 plus k equals 180 degrees. So if I add up 42 and 20, I get 62 plus k equals 180. And I can subtract 62 from both sides. These cancel out, and k just equals 118 degrees, which is also an obtuse angle. For more practice with classifying triangles, you can check out IXL and Point 4 on the 8th grade tab.